Okay, welcome everyone to the fifth and final lecture of the course Exploring the Natural Wonders of the West Coast. I'm John Compton, and I will speak with you today about exploring the areas along the Cape Fold Belt. So these aspects are covered in my book, The West Coast of Natural History. And let's start by looking at where we're going to be going. The map on the right-hand side shows you our route today. And we're going to start in Cape Town, and we're going to follow that red line up the N1, past the Tygerberg, and out to Paarl. And from Paarl, we're going to swing around to Wellington. And from Wellington, we're going to go to the Bain's Kloof Pass through Wagon Makers Valley up to Bain's Kloof Pass, which then drops us down into the Tobach Basin Valley. And we're going to go across there to the Mitchell's Pass, which will take us up to and into Ceres Basin, the town of Ceres. We're going to take a little side trip to the Hideo Pass to the north, past Prince Albert Hamlet, and then we're going to come back into the Ceres Basin, back to Ceres, and we're going to go out through the last bit of the Cape Fold Belt there, through the Karoopoort, into the Tankwa Karoo. So this is a very highly recommended trip for those of you who like mountains and spectacular scenery. And I'll try to give you an overview of the major stops and places to have a look at for the geology and the scenery, different aspects. The entire drive at a normal pace would take a good 3.5 hours. So while it's certainly doable as a day excursion, I highly recommend spending the night and coming back the next day, but you can do it as a long day, single day excursion if you wanted to from Cape Town. Okay, let's get started. First, let me put it within a somewhat larger context. This is the map I've showed you before. It shows you the topography and the offshore bathymetry. And the main features here that I want to emphasize would be the Cape Fold Belt, which is outlined by the dashed line there. Oh, sorry, let me get my pointer. So here's the Cape Fold Belt. It runs from Port Elizabeth in the east, comes straight across here towards Honklip, and then it turns radically 90 degrees to the north as the Cedarburg Mountains. And this sort of elbow kink in the Cape Fold Belt is referred to as the fold syntaxis, and it has a number of interesting features within it, many of which we'll be looking at today in this lecture. So you have Cape Honklip at the southern tip, and then you have the Elgin Basin to the north of that. You have the Worcester Basin and the Tolbach Basin, the Ceres Basin, there's the Hex River Basin, and finally there is the Karoopoort and Tankwa Karoo. So basically in the trip today from Cape Town, coming across here, we're going to join with this fold syntaxis, and we're going to basically follow it right the way through the Tankwa Karoo. So we'll be taking a section, if you like. We'll be doing a transect of the Cape Fold Belt at this very interesting juncture where it makes this radical turn from east-west orientation to a north-south orientation. Now you might wonder why it has that kink in it, that elbow bend, and that's because the tectonic forces were coming from the south with the collision of Antarctica, and they were coming from the west in the collision of South America with Africa in the original assembly of Gondwana, and that's collision, that continental collision, is what formed these mountain belts. And if we take a cross section, this is now a geological cross section cutting through the earth. Here's Cape Town, about here, okay, there's Table Mountain, that blue mountain. And we're going to drive from Cape Town across past the Tygerberg. We're going to visit Paarl Rock, we go over Bain's Kloof Pass, into Tobach Valley, up Mitchell's Pass, into Ceres, and then out through the Karoopoort into the Tankwa Karoo. So the idea geologically is you've got a basement rock here of Malmesbury shale shown in this rusty brown, and then the pink blobs of granite that intruded into it. The deposition of the blue layers here of the Cape Supergroup, which then got folded and deformed with the collision of the continents in forming Gondwana. And then you have the layer cake stratigraphy of the Cape Basin, which happened later. And then finally, you had the opening of the Atlantic Ocean with the breakup of Gondwana, and you had the deposition of sediments offshore, shown here. So starting in Cape Town, here's an aerial photograph, Mark Skinner, and you can see that Cape Town is underlain primarily by shale, Malmesbury shale, which makes up like the Signal Hill, the rump, the Lion's Rump, and the granite. And the granite is to the south. So the granite and the Malmesbury shale together formed this basement rock, on top of which you had the accumulation of the Cape Supergroup sediments. And what we have in Cape Town is the very basal formations at the bottom of that Cape Supergroup. If we want to see all of the sediments, the much thicker pile of sediments that once existed above the table, we have to go inland to the Cape Fold Belt Mountains. And that's why we're taking that trip into the Cape Fold Mountains today. And in that respect, Table Mountain represents this, what we call erosional outlier to the west of the main Cape Fold Belt. And most of the Cape Supergroup sediments have been eroded away, but this last little bit has remained as Table Mountain. So let's start by looking at the basement rocks, because we'll run into them again. They occur in the Tobach Valley, for example, and further inland. So let's have a look at them. They're very well exposed at the Sea Point Promenade. This is the picture at Sea Point here, showing you at low tide the very characteristic, almost like washerboard-like texture of these beds. They're steeply dipping, about 75 degrees. And this washerboard is produced by more finer grained beds interbedded with sandier beds, which are more resistant. Then up on the hill here, this little saddle between the Lion's Rump to the left, which is all Malmesbury shale, and the Cape Granite, which is to the right. So this is what we call a hot contact, where the granite intruded into the Malmesbury shale and formed a large body of granite called a pluton that extends south of Cape Point. Then later, these basement rocks, uplifted and eroded nearly level, had the deposition of the Cape Supergroup sediments, shown here on top, this nice stratified cake-like layering of sandstone. And there in the distance, you can see the cableway station. So there's a continuation there of the sediment deposits. If we take a close-up look at the Malmesbury, we see that it has amazing sedimentary structures and is what we call laminated, meaning that the layers are thin, less than a centimeter thick, and implies that the sediment was not bioturbated by organisms living on the seabed. So the picture on the left and at the bottom are from the Sea Point tidal pools, and you can wander in those and have a look yourself. You see amazing bedding structures within there. There's hermit crabs for scale. And then the picture in the upper right is from Van Riebeck's quarry, which is located on Robben Island. So you might be familiar with many of the dark black slabs of stone that are used, for example, in construction of the castle in town, and also as paving stones in parts of the city and in parts of Cape Town. And so it was a quarried stone used for building where it was hard enough to be used for that. Now the hot contact, which is about 540 million years old at Sea Point, is exposed at the Sea Point contact. Very easily accessible at the last parking lot to the south, right at the border with Bantry Bay. So there is the light colored granite to the right, and then the stark strips of Malmesbury shale. Here's a close-up of the mixture of the granite, the lighter colored granite, and the black baked Malmesbury shale rock. So this represents the very edge, the border, the contact between what was originally molten magma, granitic magma, that then gradually cooled at depth, and it formed large crystals of feldspar, these blocky white feldspar crystals. It also has a fair amount of biotite in the darker grains and gray colored quartz grains in it. This middle photograph is of a xenolith, a foreign rock. This is a piece of the Malmesbury shale that got ripped up and was swimming in the granite magma before it solidified. And this contact represents the intrusion of magma associated with subduction of the oceanic crust at the time. Now, in order to see much of the Cape Supergroup, as I mentioned, you've got to drive a fair distance to get to the mountains to see more. Mostly what you're driving on as you go out the N1 is the basement rocks, and primarily the Malmesbury shale. So in this photograph, taken from the start of Bain's Kloof Pass, you're looking out over the agricultural areas with all of the farm dams visible here and here of the Malmesbury basement. And that gives rise to very good soils because it generates very loamy, clay-rich soils, which are great for agriculture. And then in the distance there, you can see this large massif, which is the Paarl Pluton, okay? And there on the left side, you can see the pearls. And they're relatively small compared to the overall massif. And so this would be one of the plutons to the north of the Cape Peninsula Pluton, which we saw just now. And then there would be further plutons through to the Darling Hills and those areas. Here's an aerial shot just to show you. In the dashed lines are the outline of Paarl Rock, the Pluton. And here again are the little knobs of the granite that are exposed as the pearls. Here's the town of Paarl. And again, you can see that the Malmesbury shale, full of agricultural crops. It's transected by the Berg River flowing through here. And with the completion of the Berg River Dam, there's lots of water available for irrigation and for farming. Here are the pearls, the pearls of Paarl Rock, and they're very impressive. You can go up there, well, you have to walk up. You can drive to the parking lot at the base, and you can walk up them. There's a steep climb, but that's not too difficult. And you get, of course, spectacular views looking out from there. And it's quite a large area that's available for walking, cycling, And you can see it has a large number of these beautiful proteas. So you get the granite fynbos growing here, and it's really a beautiful, rich diversity of plants that includes a large number of different types of proteas that are quite spectacular. Now the granite is quarried locally for building stone, and the weathered Malmesbury is also mined for the mud. The weathered Malmesbury mud is used to make bricks. So here's the brickworks just outside of Paarl, and you can see this pile is about 1 million bricks. And what's interesting here is they hand stack the mud bricks, and they set internal bry fires within them, and it's called an open air kiln. So often when you drive past these sites, you might notice these big smoking piles of bricks, and they're in the process of baking. And once the baking process is completed, they unstack them by hand, load them into these pallets, and ship them off for various grades, depending on the jobs required. Okay, here's what Gondwana looked like. You can see it was a huge, what we call supercontinent, because it combined Africa, South America, Australia, Antarctica, India, and so forth. So it was a very large supercontinent. After it formed, what was interesting is it started to form a rift basin. A sea formed here in the middle at the southern end. And that's shown here in this blue patch. And what's significant about this is it was a depression, a basin that started to form. And into this basin, the erosion of material coming off the Kalahari Craton was responsible for depositing the Cape Supergroup sediments, which are this thick, 7+ kilometer thick succession of sediments that we're going to have a look at today as we drive through the Cape Fold Belt. This is a what we call a stratigraphic column. It's meant to just give you a guide in terms of understanding the stack of rocks that have formed. So on the left shows you the tectonic setting. Here is the Malmesbury Shale in that red rusty brown with the granite intrusions into it. And that formed the basement rock. And on top of that, you had the deposition of sediments within this Agulhas Sea that formed within Gondwana. And so if we look at the column, here's our Malmesbury Shale and granite at the base. They form what we call the basement rock. And then on these basement rocks, we have our whole succession of deposits that lead to the very top, which is capped by the Karoo flood basalts, which you'd be familiar with if you've been to the Drakensberg and Lesotho and seen the large, massive flows of basalt there. So at the base, we have the Grafwaarder and Peninsula Formation, followed by the Pakhaes Formation, then the Cedarburg Formation, then the Nardau subgroup. Then that's followed by the Bokeveld Group in green and the Witteberg Group in gray. And the relative length of these colors is an indication of how resistant they are to erosion. So you'll see that the Cape Supergroup is very resistant to erosion, and as is the Nardau and the Witteberg, because they're made of sandstone. The Hideo and Cedarburg formation, or sorry, the Bokeveld and the Cedarburg are made of shale, so they're much softer and weather more easily. And then on top of the Cape Supergroup, so this red box shows you the extent of the Cape Supergroup. Above the Cape Supergroup is the Karoo sequence, okay, which doesn't exist on our trip, except we'll see the lowest most Duika tillite. And then these deposits in yellow and orange, the Eka and Beaufort groups, exist within the Karoo Basin. And if you drive to Johannesburg, you'll see them on your way. So if we start then locally, here's Platiklip Gorge. Hopefully many of you had a chance to hike up it. It's the one accessible hike trail that goes up the face of Table Mountain that does not requires a lot of energy, but doesn't require any special climbing skills. So as I mentioned before, Table Mountain is an outlier, and it's an erosional outlier because of this very resistant sandstone beds of the Peninsula Formation. So when you go up Platiklip Gorge, you'll notice here this maroon reddish mudstone and sandstone. That's of the Khwa-ttu Formation. It's relatively more easily weathered than is the sandstone above it, because the sandstone has no mudstone in it. It's a pure sandstone. And you can always see this contact at where you start to get cliff formation. Okay, so these dramatic cliffs with these overhanging rocks are part of the Peninsula Formation and its resistance to erosion. Here are some more photographs. This is a close-up on the right of the lowermost Khwa-ttu Formation. You can see it's sandy, but also has mud units in it. And it shows good examples of what we call cross-bedding, which form from the ripples that moved across during its deposition. And then here is a photograph of a waterfall over a cliff face near the contact between the softer, more easily eroded Khwa-ttu and the overlying, more resistant sandstones. And again, you get these very dramatic cliff faces with rocks that are jetting overhead, and gravity will eventually pull those rocks down, and you'll have rock falls. And that's a geohazard for anyone walking or living beneath those cliffs. Now, if we want to see the rocks that were originally above the Peninsula Sandstone, we can see a little bit of the Paarl Formation, which is the next one on top of the peninsula at Maclear's Beacon, but it's not very well exposed. So what I recommend to people who want to see the rocks that were deposited above the Peninsula Formation, that you need to go inland, and that's what we're going to do. So you go from Paarl Rock and you go up Bain's Kloof. And this is there's some beautiful views on the ascent out of Paarl and got the name of the town now, Wellington. Wellington. You'll come up the Bain's Kloof Pass. There are several points you can pull over. This is one of the major pullovers, and it's looking towards, there's Paarl Granite Massif in the distance to the left, and the west coast that we journeyed to before is over here on the right. So you get some beautiful views from up there looking down into the west and south. Now, Bain's Kloof was built in 1853 and was opened in 1854. It was a major undertaking. It was built by Andrew Geddes Bain, shown here on the far left. And he used convict labor. And what they did was they built these dry wall retention walls, which are really quite amazing when you consider that they're over 150 years old and still in very good condition. And they didn't use any cement in the building of those walls. And they simply used the preferential stacking of stones to be interlocking and give it internal strength. So those are quite spectacular. This is the overhang here to Kari's pulpit. You drive underneath that, it's quite amazing. So this is a very narrow, very picturesque, beautiful drive. It's not one you do in a hurry, but if you have the time and can take the time, it really is a beautiful drive. Okay, and then when you pass through Bain's Kloof, you come over into Tobach Valley. So that's a flat, fertile valley, and you're back on the Malmesbury. And that's because the Malmesbury is basically faulted back up to the surface and it is exposed there. And we mentioned last time about earthquakes from someone who had a question about earthquakes. I'm just showing you, this is the Drosti in Tobach soon after the earthquake. And you can see, because it's made of masonry that's unsupported and quite rigid, there was quite a bit of structure. And that's one of the concerns in an area that's susceptible to earthquakes, is if you have these very rigid brick masonry walls that are not reinforced, it's very easy for them to topple. Then coming out of Tobach, enter the Mitchell's Pass, named after Charles Mitchell. It was also built by Andrew Bain in 1848, so somewhat before Bain's Kloof Pass. And this is really another spectacular pass. It winds its way up this valley, and one of the amazing things is you can stop. For example, I recommend that you stop at the toll house. You'll see it on your way up. It's really the only rest stop there with a coffee shop. That's a nice spot to stop for coffee or tea. You can look in the parking lot at the toll house and you will find outcrops of the Cedarburg Formation, the shale. And you can trace them from the road looking across. You see this band of green that runs across here that's less rocky. That's the Cedarburg Shale running between the Paques Formation below it and the Nardau above it. And in the distance, you can see the spectacular mountain range. And what you can, I don't know how well you can see this, but there are rocks layers on this side which can be projected to that side. So you have a big, what we call anticline, which is a big crest of a fold. So the idea is originally this folded rock extended right the way across. And what's happened is you've had erosion of this whole large section down to the current horizon. So really a spectacular vista there. Oh, and I meant to mention also, if you go down the road from the toll house down this road, you'll come to beautiful road cuts of the Paques. So the Paques is the one, the Paques Formation is the one that is on top of the peninsula, which would be the top of Table Mountain. And then above that's the Cedarburg Shale Formation, and then the Nardau subgroup. You can see this in other parts of the Cape Fold Belt, often quite distinctly. This shows you the same succession here, where the Paques is this lowermost unit, and it's very distinctive in that the rocks tend to form these columnar type exposed rock outcrops, which is called tombstone weathering, because they seem to almost form like a tombstone. And that's because the Paques sand, pebbly sandstone, is a glacial deposit and it is massive. So it doesn't form well-formed layered cake type deposits. Then you can see this very distinct line across here, and that's a very clear contact between the Paques and the overlying Cedarburg. So the Cedarburg, again, is very distinctive and easy to spot because of these relatively smooth green slopes. And that's because it is less sandstone in it. It's mostly a siltstone, and it has more nutrients in it. It weathers to give a slightly more nutrient soil. So examples of the Paques is blown up here. This is a drop stone within the Paques, and the pebbly sand that's very typical of it. This here is the dark, finely layered Cedarburg Formation rock, and often not very well exposed. So you have to really hunt for it to find good exposures that look this good. And then above that is the Nardau, which is this very resistant sandstone. And it forms these spectacular cliff faces, once again, and beautiful arches. This is the Yzerfontein Arch in the Cedarburg, and very typical of the Nardau. Then once you're in the Ceres Basin, it forms really like a bowl, okay? It's like a bowl. So what's happening now is the Nardau is the ridges around the basin, which are dipping down in, and the trough of this bowl is filled with the Bokefeld Shale, which makes for also, like the Malmesbury Shale, makes for good soils and is very productive for farmers. So obviously no one's going to farm these very rocky, rugged, steep Nardau mountains, but the valleys in between provide beautiful conditions for farming. And you get these really fertile crops, and this is looking now to the north, and that's the northern limit of the Ceres Basin. It's a very large basin, and to get an appreciation of the basin, I often recommend that people go over to the Hideo Pass. This is from Roger Stewart's recent winter school class that I took. And it shows you in yellow, the current road for the pass. And there's a lovely lookout point right there. It's a parking area. You can pull over safely and park there. And what also is shown on here is the scar of the old Hideo Pass cutting through this way. So you can see that the modern road was designed to have a lower gradient and to curve its way around the slopes building up this way. And I highly recommend a drive up to this lookout point. This shows you a view. So now we're looking across this huge Ceres Basin. There's the Nardau sandstones forming those mountain ranges to the far east. And these ridges are all part of the Bokefeld Shale, as is the valley floor where they are farming. And as you mount up there towards that lookout point, you'll see this view, which shows again the Nardau at the base, then the Bokefeld Shale, which, like the Cedarburg, you see gives these slopes that are gentler and smoother. And then you go into the sand-rich units, like the overlying Witteberg group, and you get these cliff faces. So very dramatic contacts. You should be able to pick them out with your naked eye. You just follow it right along that transition from smooth, steep, but smooth slopes to almost really cliff faces and overhanging cliffs there. Now the Bokefeld group, the lowest most formation is called the Hideo, and that's what the pass is named after. And in that, if you drive further along, if you go beyond this lookout point and work your way around through here, you'll see that there's a section above you. There's a parking area off the road, a gravel parking area. There's a place where they have made a big trench. And in that big trench, you can fossil hunt in the Bokefeld Shale. You can find brachiopods like these two. You can find bits of trilobite. This is a trilobite head. And this is a crinoid stem. So it's a very fossil-rich deposit. And we get, it's possible then to get good age control and an idea of the marine depositional environment in which they formed. Then if you leave the Hideo Pass and come back down into the Ceres Basin and keep driving through to the end, you come to the Karoopoort. And this sign is 50 kilometers from Ceres, so that's how far it is from the town of Ceres. And in doing so, you drive through that Witteberg. Okay, so that Witteberg is this group at the top of this mountain. And as you go through the pass, which is over to the right, this is the Witteberg exposed. And you can see it's highly deformed and tilting. And then you come out into the Tankwa Karoo. This is on the 355, the dirt road. And you can see that it's this nearly flat Karoo, very typical of the Karoo. And that's because we've left behind the deformed fold belt to the south, and we've now entered into the Karoo proper. And if you look from there, towards the Cape Fold Belt, you see dramatic deformation structures here, showing you the intense forces involved in the collision of the two continents and the mountain building that resulted to form the Cape Fold Belt. And if you drive further out on this road, you'll come across outcrops. This is probably one of the bigger ones near the road. And this is of the Duika Group, which are the ones that are on top of the Cape Supergroup sediments, first formation within the Karoo succession. And you can see it's like a dog's breakfast. It's got chunks of all different sizes of rocks all jumbled up inside. And that's because this is representative of a glacial till, which has been cemented into what we call a till-lite. And that means, and the evidence for it being glacial, there are these striations in the pebbles as they got scraped by the ice moving them over the bedrock. They got grooves in them, and this is proof that this was a glacial type deposit. Then you come out onto the Karoo, and there's beautiful vistas from the Tankwa Karoo out over to the Great Escarpment in the far distance. And this would then go up onto that Southern African plateau that we mentioned yesterday, that elevated terrain that goes all the way across beyond Johannesburg and to the north to Zambia. And here, these little hills off here in the distance, these are bits of Duika, and you can, as you drive on the 355, you can stop and look at the one on the right to the east, and you can hike up it, and you get beautiful views from there as well. So it's a lovely, really a lovely terrain for driving through, as well as walking. I went on the Tankwa Camino, which we walked from Calfinia to Ceres, 256 k's. And it's really a spectacular landscape to be in. Now, the Karoo as a basin represents here in the red block. So we went through the whole succession of the Cape Supergroup, ending with the deformed Wittenberg sandstones to the Karoopoort. We've gone into the Duika Tillite, which is this basal green bed here at the base. And then if you look across here, you're looking at exposures of the Eka group. And above those would be deposits of what's called the Beaufort group. And then capping the whole Karoo succession, as I mentioned earlier, are these Karoo flood basalts, very well exposed in the Drakensberg Mountains. And of course, exposed by a large number of feeder dikes of dolerite sills and dikes, and those are, you see those all along the N1 on your way to Johannesburg, for example. So if we zoom out and look at the whole basin, here's Southern Africa and South Africa, and here you can see the blue at the southern end here. This is all the Cape Fold Belt that we've just driven through, and then these layers, starting with this dark brown Duika, then the Eka, then the Beaufort, going up to this purple of the Drakensberg group. This is the whole Karoo basin. And one thing that's very interesting about the Karoo basin is sedimentary rocks, and they haven't been terribly deformed. They're mostly still layer cake deposits, but they've been cut by and intruded into by basaltic lavas. And these erupted and formed the Drakensberg and all of these feeder dikes, cross sections shown down here below, that led to all the kopjes you see on your drive across the Karoo. And they heralded the breakup of Gondwana. Okay, so that big supercontinent didn't last forever. It eventually started to break apart, South America going to the west, Antarctica to the south, and so forth. India went up and collided with Asia. And so if we look at the rock record for our area, we've taken our drive from the Cape Town area, looking at the oldest basement rocks of Malmesbury and granite, and right the way across through the Cape Fold Belt Mountains and into the Tankwa Karoo and the Karoo in general. And that covers a large part of geological time, but not everything. And then there's a gap from about 180 million years ago till about 130 million years ago with the development of the breakaway of South America from Africa. And then you had the deposition of these more recent deposits offshore from erosion of this material on land being carried by rivers and wind to the coast and being buried offshore. So that's the whole sequence of time and events that we have for this part of the world. Okay, and that pretty much finishes the 5-part lecture series. I just want to remind those who are interested that there are 3 books that I've written. The Rocks and Mountains of Cape Town, Human Origins, How Diet, Climate, and Landscape Shaped Us, and then most recently, this year, published West Coast and Natural History. And just to remind everyone that if you're interested, you can find out more about those books and read blogs and watch some YouTube videos if you want, up on my website, which is jonascompton.com. And if you're interested in ordering any books, you can click on the order form and it will download a PDF that you can fill out and just send that to me at this email address, john.compton@uct.ac.za. And so with that, I will finish and I will open up to questions. And I wanted to start in terms of the questions with a question that I noticed only too late yesterday in the chat. And that was someone had asked a question about the origin of the offshore phosphate deposits that I mentioned yesterday. Remember that there are phosphate deposits off of much of South Africa and very large phosphate deposits off of Namibia. The origin of these phosphate deposits is from essentially the very intense productivity of the oceans. So remember I said that the Benguela upwelling system was driven by wind that produces upwelling of deeper, colder waters. And those deeper, colder waters are also more nutrient rich. And when they enter the sunlit waters, algae can bloom and fish can eat the algae and the whole food chain is fed and there's a huge amount of production. And there's a lot of fecal pellets that drop to the seafloor. It's very organic rich. And then the decay of those organic deposits can lead to the release of phosphate in the sediment. And that phosphate can then combine with calcium to form phosphatic rocks. So that's how it forms. So it's a consequence of this very intense upwelling and productivity. And then over long geological periods, the sequestering of the phosphate in mineral form and the reworking by sea level changes results in those phosphate deposits. So I hope that helps clarify at least briefly how those phosphate deposits form. And I'll now open it up for questions. Yes, Francis Hemp, you have a question?
Has anyone done a road log, a sort of geological road log of that trip you've just done?
Not specifically of that trip. There are books that would cover parts of it. For example, John Rogers has written a book. I don't know if it's still available. And Geological Journeys, I think, covers part of it or aspects of it. That's by Nick Norman. So there are some now geological guides that are available as books. There are also geological guidebooks within the geology department. Those are a little more technical, and they're not very nicely produced because they're sort of photocopies of photocopies, if you know what I mean. So unfortunately, there isn't really a comprehensive guidebook that way. I guess the only thing I would recommend is if you look at my Rocks and Mountains book, a lot of the aspects in there would cover see on that road trip. So that would probably be a useful guide to take along with when you do that route. Now, it doesn't talk about it in sequence, but I think you can probably put it together based on the different walks that are talked about and the locations. I guess you could take this lecture as a YouTube video on your phone, and you could play it back as you drive. That's an option.
Okay. Sorry, you mentioned, I think you mentioned the Camino from Calvinia to Ceres. You said you've done it. You said did you say you'd done that trip and that hike or walk?
Yes, I did.
And can you comment on it?
Yeah, I guess I would recommend it to people who are interested, who enjoy walking in the middle of nowhere. So that trip is from Calvinia to Ceres, and you basically just follow the R355 road, and you camp at night on farms, and they do all that arrangement of where you're going to camp, but you have to set up your own tent and so forth. And so it's it's 10 days, 256 Ks. So you're doing 25, 30 Ks a day. So it's a fair amount of walking, but if you're in reasonably good shape, it's doable. And they have a good support group there as well. So if you're interested, you can check out their website. I know that with COVID, things were delayed, but I think they're reopening. And in fact, I'm going next week to do the Hontomberg walk, which is north of Calvinia. So it's well worth checking out if you like to walk.
Thank you very much. Thank you.
Pleasure.
Hi. Tell me, when was the last volcanic activity in southern Africa, and where was it?
The most recent volcanic rocks date from about 45 million years ago. And they are the Kloof Mountains in southern Namibia. I don't know if you know where that is, but there are volcanic rocks there. Of course, I believe those are the most recent. But in my West Coast book, I do mention that we do get volcanic deposits that are very recent, and those are in the form of pumice. Now, pumice is a volcanic rock that gets blown out of the volcano as magma, but because it's so full of gas, as bubbles, it quenches as a very porous rock and it floats. Some people use it in their bath as an abrasive. And if you walk along the beaches on the West Coast, even the South Coast, you can often, if you keep an eye out for it, you can often find pebble-sized pieces of pumice. And I had a student who did a study on that pumice, and she was able to identify it as being perhaps associated with the Tristan da Cunha volcanism. So Tristan da Cunha has volcanism that can occur under the ocean. You don't see it erupt on land, but it produces this pumice float that then eventually the ocean currents send our way, and it ends up on our beaches. So in that sense, we do get volcanic rocks deposited on our shores that are very recent, but the volcanism itself took place far out at sea. The most recent in-place volcanic eruptions would be, I believe, the Klinghardt Mountains in Namibia, dated at 45 million.
Right, thank you very much.
Pleasure. Francis, have you got another question, or is your hand?
Yeah, no. Do you think there's oil in the Karoo Basin?
Well, as you know, some people, well, people have looked for oil in the Karoo Basin, but so far have not found it. And you may also be aware people are trying to look for gas, fracking of gas, but no one has really found it yet. So the jury is still out. I suspect there may be some, but it might be hard to find, and it may not be worth exploiting. I think if there were large amounts and it was clearly there, we would have found it by now. There is oil that's found offshore in the south coast, and that's been produced, but not huge amounts. So the amount of natural hydrocarbons in southern Africa is quite limited. And I don't think the Karoo Basin is likely to be a huge source, but you never know. So you have to stay tuned, see what they discover. Yeah.
I have another one. If I could ask something about yesterday's lecture, please.
Sure.
You mentioned the Muscom Mountain.
Right.
We've been up and down the Hifberg Pass a couple of times, and it's very spectacular, especially the view from the top.
Yeah.
Could you give some information about when the Muscom Mountain formed, how long ago, the geology of it, etc.?
Yeah, well, basically the Muscom represents the cutting edge of the continent from erosion. So remember I mentioned that Gondwana eventually broke apart and South America went west. And when that happened, you had this huge erosional event, because when you have breakup, you get sort of this doming, and then it breaks apart like the East African Rift Valley today. And during the Cretaceous, that would have been after the breakup, it was much warmer and wetter here. And so you had quite rapid erosion. So when I showed you that picture the other day, you have that coastal plain, very flat, and then suddenly, boop, there you have the escarpment. So the interpretation is that that escarpment used to be all the way over on the coast. And what's happened is you've simply eroded all that material back. And you're right, those valleys going up through to the Muscom and in that Nouveautville area are spectacular. And they're spectacular valleys that cut up into, going up into the escarpment. So those are erosional features of a very long time ago and ongoing, but much more slowly today, of active erosion.
Right, thanks a lot.
Pleasure.
Thank you very much. Thanks, everybody. Thanks to the audience for participating, for your questions and your patience. And once again, John, thank you for such a wonderful presentation.